All right, number 17. So in the piecewise function, they want to know what the value of the limit is. And this k with the little negative, if you guys remember, it means from the left. So here we have a piecewise function, and the piecewise function says we have this when x does not equal k. And think about this. I'm going to pretend that k equals 5. So I'm going to pretend that we have a rational function x squared minus 25, because that's what k squared is, over x minus 5. So if you guys remember from like rational functions, that means that this would have a vertical asymptote potentially at 5, or maybe it could have a hole at 5. And if you guys remember, the way that we figure out if that's a vertical asymptote or a hole is we factor the top. So this is difference of squares, that'd be x plus 5x minus 5. And we see if the factor cancels out or not. All right, so these would cancel out. So that means that, that there would be a hole there, okay? So this right here, we're picturing a rational function. We could say it has an x-intercept at -5 and it has a hole at +5, okay? So this right here means that there's a hole at k. Now, if you guys remember, all the limit really means is at that x value, what should the y value probably be for it to like make sense? So what we have here is we have some sort of curve, and it skips a point right there. And they're saying, what is the left-hand limit, or what y value does it look like it's supposed to be from the left side? What y value does it look like it's supposed to be from the right side? Well, if we look at this, we know that anytime you have a hole, the limit is actually there. There truly is a y-coordinate that was supposed to be there. And at a hole, we get the y-coordinate that was supposed to be there by plugging in the x value to the leftover factors. So in this specific case, for the k values that I chose, I said that there was a hole at an x value of 5. So if I wanted to find the y-coordinate of that, I would say plug in 5 to the remaining factors. 5 plus 5 is 10. Okay, so it looks to me like k equals 5 and 2k is the answer, which kind of fits over here. Now, if you're not convinced by doing just one situation, you can do it again. We could say x squared minus 9 over x minus 3. Thinking about that as our rational function, we could say, all right, let me factor the top. And then I'd say, oh, it's like there's a hole at x value of 3. So if I want to find the y-coordinate of the hole, I plug the 3 in. 3 plus 3 is 6. And so the y-coordinate at the hole would be 6, and that means the limit at k would be 6, which again is 2k. All right, so remember the limit is just what it seems like the y-coordinate should be. And anytime we have a situation like this, we're talking about a rational function. We have a factor that cancels, so that means it's a hole. So we're thinking if we have the x-coordinate of the hole, what should the y-coordinate of the hole have been? All right, and you get that by plugging that value in. All right, number 18 is a pretty straightforward limit problem. It just says if the x value is 3, what y-coordinate should we probably have? Anytime I can directly plug in that x value, I'm going to try that and see if it works. It helps if I actually plug it in for x. 3 squared minus 3 times 3. There we go, plus 7. So 7. The y value there is 7. Okay, so here it was what y value should we have. In this one, this is just a quadratic, so we're not going to have any holes, we're not going to have any asymptotes. If they're wondering what y value should be there, it's the y value that already shows up there. All right, number 19. So this one says that we have a triangle, we have side, side, side. So anytime you see that, you should be thinking law of cosines. And they're asking us to find the angle across from side 10, which happens to be the biggest angle. So we're going to use the law of cosines. We're going to say 10 squared, because that's the side across from it, equals 6 squared plus 5 squared minus 2 times 6 times 5 cos of angle x. And so what I'm going to do is I'm going to subtract the 6 squared and the 5 squared over. So I've got 39. And then I'm going to go ahead and divide that by negative 2 times 6 times 5. And I'm being careful to put this in parentheses because I do want all these things multiplied together, but I want them like multiplied in a chunk that's being divided. So I've got negative 0.65 equals cos x. So now what I'm going to do is I'm going to go ahead and cos inverse that decimal. And my answer is really small because I should be in degrees. So let me do cos inverse negative 0.65 again. There we go. So the reason it said 2.27 is it was giving me the answer in radians. And the nice thing about here is they did not put those answers off to the side if you had kept your calculator in radians on accident, so that was kind of nice of them. So in degrees, our answer is 130.5. All right, number 20. We have a large fish tank. We have this equation. X is the number of pebbles in the tank. How many pebbles are in the tank if the water is 58.3? So I'm going to say 58.3 equals ln of 1 plus x plus 52.4. And so first I'm going to go ahead and subtract the 52.4 over 5.9. And next, to get rid of the ln, I have to do a base of e on each side. So I have e to the 5.9 equals 1 plus x, and then I can go ahead and subtract 1. So e to the 5.9 minus 1, 364, so about 360. So the answer is A. All right. Now, if you did not remember how to do this by hand, then you can actually solve this in your calculator. So what I'm going to do is graph this equation. So I have ln of 1 plus x plus 52.4. I'm looking to see where this intersects with 58.3. So in my window, that means that my y max has to go at least up to 58. So what I'm going to do is I'm going to change my y max to be 100. Now my x values could be 360, 300, 270, 200. So I need my x values to go up to like 400 so that I can see where these two graphs cross each other. I almost said graphs cross each other. All right, now my picture is not very good with this, but the calculator can handle it. So I'm going to say, find the intersection, and it found the answer for me, even if I didn't know how to do the problem.